Hello everyone! Have you ever wondered how scientists can find a tiny amount of a specific substance in a complex mixture, like a drug in a blood sample? They often use a powerful technique called liquid chromatography mass spectrometry, or LC-MS. Today, we're going to break down how this amazing machine works in simple terms. Think of it as a two-part process, first separation, then identification. The first part is liquid chromatography, or LC. This stage acts like a sorting race for molecules. It starts when a liquid sample is injected into a stream of fluid called the mobile phase. This fluid pushes the sample through a long, thin tube called a column. The column is packed with a solid material, which is the stationary phase. Here is where the magic happens. Different molecules in the sample mixture have different attractions to the stationary phase. Some molecules stick to it very strongly. Others barely stick at all. Because of this, the molecules travel through the column at different speeds. The ones that don't stick much are washed out quickly by the mobile phase. The ones that stick a lot lag behind. This separates the original complex mixture into its individual components, which then exit the column one by one at different times. Now that the mixture is separated, we need to identify each component. This is the job of the mass spectrometer, or MS. As each separated molecule leaves the LC column, it enters an interface that connects the two machines. This interface, called an ion source, does two crucial things. First, it turns the neutral molecules into charged particles, called ions. It usually does this by zapping them with a high voltage. Second, it evaporates all the liquid, leaving just a gas of ions. The mass spectrometer can only analyze charged particles in a vacuum, so this step is essential. These newly formed ions are then guided into the mass analyzer. Think of this as a super precise scale for molecules. The analyzer uses electric or magnetic fields to separate the ions based on their mass-to-charge ratio. Lighter ions are affected more by the fields and their paths are bent sharply. Heavier ions are more resistant and travel in a straighter line. After being sorted by mass, the ions strike a detector. The detector counts how many ions of each specific mass hit it. A computer then plots this data, creating a mass spectrum. This spectrum is a unique fingerprint for the molecule, telling us its exact molecular weight. By combining the separation from the LC with the identification from the MS, scientists can confidently identify and quantify virtually any substance in a sample. And that's the basic principle of how LC-MS works. Thank you so much for watching. If you found this explanation helpful and want to learn more about the tools of science, please show your support by liking this video and subscribing to the channel. It really helps us create more content for you. See you next time.